My name is Saúl Díaz, and I'm an Android developer from Spain. I've been doing Android since 2010. And today I'm going to tell you a horror story. And it is a horror story because it could happen to any of you at any given time. Nobody is safe, and that's the horror of that's the terror this story makes. Our story begins on June 21st of this year, no so long ago, at the Chicisimo command center. We have just released a new version of the app with some improvements on how we handle some animations with the recycler views. We were okay. All right. The animations with the recycler views, we were actually quite satisfied with the work we have done, and everything was going smoothly. But suddenly, something happened. The users started complaining that the application was not working, that the application was not loading. This feedback is actually taken from both our email and our Play Store comments. It has been translated on English because it was on Portuguese and Spanish and Italian. Okay, so basically what we had is that the users were complaining that the application was not loading. Some users weren't even able to register. So what was going on? Had we introduced a bug in production? Okay, this could happen to anybody at any time, but how could have this happen? In Chicisimo, we live comfortably because we have very small release frames. We release every week or every 2 weeks, small features, small incremental features. And usually we have 3 lines of defense to avoid that the bugs arrive into production. If you are here, you are probably all of you know this, but our first line of defense is a suite of unit testing. In Chicisimo, we have it divided into suites. One is what we call the domain suite, which tests the data sources, the repositories, use cases, and even we can go up to the presenters because they are pure Java. They are done with JUnit, and we attempt them to be end-to-end test. Our coverage is around 60-something. It's not perfect, but it's solid. It works for us. It allows us to detect defects early and avoid that anything trespasses that barrier. And then we have another suite for UA testing, which we use Robolectic and JUnit, and it's around 40-something. And it's also focused on key components of the system, like common views or some components of the application that are common to most of the screens. Our second line of defense is obviously manual QA and dogfooding. We attempt to ship the features early internally, so we can test them as soon as they are on a shippable, not exactly a shippable state, but where they can be used, so we can detect maybe some specs that were not covered by the original documents and these kind of things. And we also have several devices where we can test with different file formats, different makers, different API levels, which is something normal too. And our third line of defense is shipping. We consider shipping a major asset. For us, we don't try to be very dogmatic on our releases. We release when we are ready to release. And if we require to do additional releases for bug fixing or maybe diagnosing an error, that's something that we are not afraid of doing. All the production releases go through stage rollouts on Google Play, and we require that they stay at least 24 hours on monitorization at 30%. And even when we do full release, we release at 99%. So in case anything happens, we can roll back that release for the earlier version, which is supposed to be stable. But anyway, this bug had permeated all these lines of defense, and we had no clue what's going on. So what's the first thing we have to do as developers? OK, we need to gather intelligence. And how does a user, a developer, gather intelligence? Well, the first is, of course, Crashlytics, or your choice of bug reporting tool. It's very useful for crashes and unexpected situations, but for this kind of misconduct, misbehavior the application was having, it is not that useful to get some info of what's going on through Crashlytics. And of course, the next tool a developer should be able to use properly is Gmail. When things escalate, I directly talk to the users. I notice the user support team that I'm going to take care of that. And I talk with the users. Why? Because I know how the application is made, and I know the precise questions I need to ask. I can ask for videos, I can ask for pictures, maybe I can ask for some kind of behavior that I know that it is a weak point in the application or in the feature to see if that's the case. And another tool I use as a first method of learning information are analytics. Okay? In the case of Chicisimo, we use Mixpanel, and we run a couple of technical funnels there. One is for registering, because our registering process passes through different stages, and for push notifications. And we can even know on a scale if the registering is working fine, or if the push notifications are being received and displayed properly. And this has saved us from some issues in the past. Well, what I got in conclusion from talking to the users is that basically the application was not loading. In Chicisimo, we use a variety of clean architecture. We are not going to discuss it. And it's divided in several layers. So the most probable suspects of this misbehavior will be one of these four. First, if the network was not working properly, I talked with the backend team. Everything was green. I discarded that OK HTTP and retrofit, which is the backbone of our network, was failing because they are all well-known and well-tested libraries. Our use cases, as I said, are covered with tests. So we have a confidence that even if in error conditions they will be answering properly. And then this would leave us only two suspects, or callbacks backed by a bus, or a UI component we call the progress switcher, which is shared among most of the screens, which is basically a view that allows us to change between a spinner, the actual content on the screen, and error messages if the response from the use case is a failure. Okay? Both of them are also covered by tests in our UI suites, but who knows? Well, it was clear that we were against a Heisenbug because I wasn't able to replicate the issue. A Heisenbug, it's a bug that disappears or alters its behavior when one attempts to study it. I couldn't replicate the issue. I tested all the devices twice. I ran tests and additional tests on the components that were affected. And nothing could be pointing that there was an error on the code. But the error was there. The behavior was actually real because I've seen the videos from the users. So the only thing that I have taken into consideration was that thanks to the analytics information we gathered from the users by crossing the information with them, is that most of them were located geographically on South America and Central America, where most of the reports came. And occasionally in Italy, Spain, France, a random user will complain that they were having the same bug. So how can I fix a bug that I don't know how it's happening? Well, the easy way is to be there when it happens. Okay, Crashlytics is kind of cumbersome for this, but what we did is to enable remote logging on the application. Papertrail was a remote logging tool that backend was already using for diagnosing things on their end. So the only thing I had to do is to install an integration library, and I started logging information that I might find useful to the tool. What I did was to agree on a similar format they have. So I will know the component that was failing, a log tag for analyzing several events, information I might need to add to know what's going on, and then some analytics information like which was the user ID affected, so I could even directly talk to them, knowing what was going on, the installation ID, so I could cross the information between backend and analytics and the client, and then some information about which model of the phone she had, or which API level was running, and which build of the version. So I could see evolutions, I could find a pattern on models, maybe API versions, and this is what I found. I found a backend bug that what was happening is that the main screen was always expecting to have a feed, to have content. But it happens that depending on the load of the server, new users registering might not receive any content. But it will be OK. OK, here's your feed, and it is empty. And in that case, the screen wouldn't switch to any error condition. OK, it was a bug on both parts. So yeah, we found it. No, actually no. The reports kept arriving, and it was the same. But it was OK. We had found a bug. So what was next? Well, to know your enemy, you must become your enemy. So how could I simulate that I was a woman in South America? Well, the first thing I tried is to broaden my set of devices. I use some tools online that allows you to manually deploy APKs to other remote phones. I use Samsung Remote Lab, Amazon Web Device Farm, and I also talk with people on the Spanish community who are working on bigger companies to try and give me a hand installing the version on their testing phones and see if there was something that I had missed. But nothing. We couldn't still replicate the issue. But then I thought that, well, maybe it's something related to the infrastructure. So I started using proxies. I fired up my Genymotion. I look up for a proxy web list by country on the internet, and I decided to connect to the most loathsome, worst scored, the worst proxies I could find on Sao Paulo. And actually, I could replicate the issue. And when I was looking what was causing trying to find what was the cause of the issue, then I found this on the story of my GitHub. It's an interesting typo, but it also has another name. Oh, also, never code with your cat around, because probably will happen things like that. But this also has another name, which is facepalm. OK, I had fucked it big time. But, well, at least the fix was easy. I just needed to write back the number. But there was something good of this. I deployed the version, happy that I had finally found it. And then what I did was to apply mock web server to my test suite. Actually, we were mocking the responses using Mockito. But now, applying mock web server, we could test a more broad conditions of the app. We could now test what would happen when there would be a timeout, or when we were having an SSL handshake that is failing, or the server cuts the connection. And we learned a lot on how the application actually behaves on failing networking conditions. So good. We have solved it. It was time to go home. But no. Actually, the users kept complaining that the app was going very slow, that it didn't load, that everything was the same. So how could this be? I had fixed both errors. There was nothing that could be failing. So the only way I could do now is look beyond the application. Maybe there was something that was that I had missed, that I haven't tested yet. So I had to change which would be the stack of the error. Backend still were reporting that they were having no issues. The workers were reporting fine. The API was up. And I tried to release a version without OK HTTP and retrofit. And it was the same. So the only thing that could fail in now is that if there was a problem related to the infrastructure. But it was hard to know precisely what is going on. Maybe it's an ISP. So my choice was to, I really wish I could go to Brazil and go to the house of one of these girls and hook my phone and know what's going on. I did it on the past. I had a user who were having problems with the registration, and we agreed to meet, and I did a on-field debugging with her phone, and in the end it was a custom keyboard that was not behaving properly with a normalization algorithm we have for it. So what I wanted to do is what's really going on these phones. I want to test them from inside out. And then my prayers got answered. And I found that there is a tool called Visor.io made by Kushik Dutta, which is the guy who invented the first recovery, Clockwork mode, and work on cyanogen mode that allows you to remote debug a phone that is not actually in your vicinity. There are very 3 steps to make Visor work. You have to make the woman install, well, the person. I'm talking always about women because Chicisimo is a women-oriented application. So all our users are basically women. I had to make her install the ADB drivers. They can bundle on an install. It's not bad. Then you would need to install Visor on your phone, on the phone that you want to be debugging, and make her install Visor. They have several flavors, but the easiest is to install a Chrome extension, and you will be good to go. So what we did is we put a bounty on the bug and tell our users that if they will help us to diagnose the bug, we would reward them for their time. Actually, it takes like, well, for a power user, this will take no more than 15 minutes, but you know, some people are not very tech savvy, and in the end, I could spend up to 2 hours working with them. But we paid it like 300 zlotys, like 70 euros for just being at home listening to me. So it was an amazing experience. And yes, we found that we were having systematic timeouts to the API. And we didn't know what was going on because the infrastructure and the backend team said that everything was fine. And this happened systematically no matter which amount of timeout I put. So if it was 60 seconds, it would take 60 seconds and then fail, 40 seconds and then fail, 20 seconds and then fail. No matter which amount of timeout I put, 2 minutes, 3 minutes, it was like that. So I talked with the infrastructure team and said maybe it's some ISP which are blocking the connection to our main servers, which are in Ireland, in Amazon. So they agreed to deploy 2 SSL proxies in Sao Paulo and North Carolina. And nothing happened. I mean, for the people who were having the issue, they were still having the issue. But for the people who the application worked perfectly, we reduced the response times by a 50%, which was quite a good accomplishment. So it was really cost effective, and we left this solution. But still, now we knew something, that it was connection based. We didn't know what it was, but we have it like kind of isolated. So now, before pushing even more work, because we have spent like 2 weeks working on this, we decided to know, OK, but what's the real amount of users that are having this issue? Because maybe it's not worth to fix it. You know that unhappy users usually complain more than happy ones. So maybe they're just making a lot of ruckus, but in the end, they're just like 20. And we use 3 works in order to assert that. First, we use Stetho. Stetho is a Facebook tool that allows you to manage, intercept the calls and know what was going on. It's kind of similar, I think, for what Google released later on Android Studio with a new profiler. And then we also use Firebase Performance and Papertrail to have a clear benchmarking on how the app was taking time on consuming the information. And then we did an in-house thing with our servers and our logging system. Basically, what we did is that we would send a request to the server. The server would, I know this is very, very crude and very not sophisticated, but well, we were desperate and we needed to do this kind of stuff. We would send a request to the backend would return me the current server time. I would calculate the time gap and would log the time taken with every request from the client and send that information to the server so we could see the both ends how well they were performing. And using a tool from Bitly, which is about crunching data and analyzing statistically stuff, we crunch our roles, and we saw that around 3.43 people were having the issue, but then we moved to Firebase Performance too, and Firebase Performance have analytics for the benchmarking of your API, and it actually outputted that we're more like a 6%, I'd say. Okay, so there was a significant amount of people, and we had to press on. We couldn't leave those behind. On the other hand, Stetho was a very useful tool for diagnosing the times and all that, but we were already doing it in-house and on scale because Stetho only works with individual devices. So for us, it was kind of a fail, but it is a useful tool if you don't have this another way to look at those connections. So we knew that it was the connection, but we needed to go further. We needed to know where the time was being lost. Maybe it was on the DNS resolution, or maybe it was the SSL handshake that was failing. But there was something that was amiss. And I tried to find some tools that allowed me to have this level of network introspection, and I didn't find any at all until by browsing OKHTTP issues. Okay, I found a 2013 issue talking about developing an analytics API. This analytics API would allow me to introspect precisely what I was looking, every step of the connection and how it performed. It has been released on alpha on 3.90, and they announced that they will have it's on alpha now, but that they will have it finished by in a couple of months. Okay, but by then, what I had to do is to go to OKHTTP GitHub, find the precise branch, clone it, build my own flavor of OKHTTP, enable the API, and fill the gaps. And this allowed me to overcharge my login. Because now I could, by now I could know which endpoint I was calling, to which server. Remember that we now had 3 servers, one in North Carolina, Sao Paulo, and Ireland. And then finally could check which part of the connection were taking how much time. In this case, I could see the DNS resolution, the SSL handshake, and the actual connection. We didn't care about the bandwidth because we knew it wasn't a bandwidth issue. And I won't forget when these numbers start coming, and I had finally found what was the root of the error, really. But something wonderful happened almost at the same time, and it's that our designer, Josue, had just come from a month in Budapest in remote nomadic, yeah, and he came home, he installed the latest version of the app, and he told me basically this: dude, this version you sent me is working very bad. It takes a lot to load. It's not working good. What's going on? And I told him, OK, I will be tomorrow by your house, and I will investigate what is going on. And I brought all the tools I have amassed during these 3 weeks, all my devices that were working fine at home, and we started running tests on his connection. And this is what I found. When I arrived and I fired up the emulators were working fine. His phone was working, were having the issue. Then I connected my phones, and they were having the issue. But then we tried to use 3G. 3G worked perfectly, and then we tried to tether the phones to their Wi-Fi through another means. First my laptop, and then another phone. And in those cases, it worked perfectly. So I told him, man, what kind of network equipment do you have? And it happens that we share exactly the same ISP, the same version, the same router, the same ONT. This one is our designers, and this one is actually from my house. So what was going on? We were sharing the same equipment. We live 30 kilometers away from each other. So why was happening this? The answer is, I don't know why this happens, but this is what it happens. When we resolved the DNS of the Chicisimo's server, we received 2 IP addresses. One is an IPv4, and another is an IPv6. In 3G, at my place, and wherever in the world, we receive first the IPv4 in an array, and then the IPv6. If the IPv4 comes first, we query the server, and the server responds beautifully. But in Josu's Wi-Fi and on the 6% of all our users' homes, they receive the IPv6 first. And this, when we query the IPv6, the server stalled the connection. And this was what was causing the slow response times, because the application would wait for the timeout to happen if there were a timeout. Remember the configuration change I had to make earlier on. So if you have no timeout, the application would be frozen forever in time on the spinner, because the connection never was severed. If you put timeout in seconds, it would wait all that timeout in seconds before responding with an error. So this is the actual fix. It's a custom DNS resolver you can push on the HTTP library, which basically the only thing that it does is to order the IPs, putting on the top the IPv4, and we could release that immediately, and everything was fixed. And then I notified the infrastructure team. It seemed that there was a misconfiguration on the load balancer or something like that that was stunning the connection. So the wrap-up of all of this, we spent 4 weeks of development time finding this bug and fixing this bug, and that's a lot of money, because I'm the only developer on Chicisimo, on Android developer, sorry, on Chicisimo. So when I'm fixing the bug, I'm not developing I'm not doing any new features. So it's like we lost twice the money than my 4 weeks of work. We lost 15,000 net users. This means that if you take the number you have at the beginning of the issue, and when we fix it, even with new installs, we have less users than we started with. And we lost 0.03 rating on the Play Store. It should seem that it's not that much. But actually, it's going to take us 9th month to be on the same levels as we started. But not everything was bad, OK? We improved our test suite. We gained more confidence on the things that we released to the public. And our UX, remember that now everybody was having a working version of Chicisimo, and all those women in South America were experiencing a 50% less waiting time than before. And it was also very good. We got a lot of tools, and we learned a lot of strategy on how to use it. So when a critical bug appears again, we're going to be faster and more focused to the point, and we have and we also learn a lot of insight on how our application behaves in the real world, how our application behaves when the things are not going so well as being in a Wi-Fi in your home. And for wrapping up, keep calm and be scientific. Apply your scientific method when you are debugging the bugs. What I did all the time was make some observations, make an hypothesis of what was failing, and then try to prove that hypothesis by a fix, by the logs, by tools, whatever, and repeat. I failed during 4 weeks trying to find the bug, but then I started narrowing the scope of where it could be. Engineering comes from the Latin word ingenium, which means, in English, it means ingenuity, which is the way to come up with new ideas in order to solve a problem. So try to lateral think your bugs if you have it. Try some tools, try some different approaches, like we did with the bounty, like we tried with the logs. Sometimes fixing a bug or diagnosing where a bug is not as easy as going straight forward. Maybe sometimes you need to make a turnaround. And failing is fine as long as you learn from the experience and you get new information and new capabilities from it. And that's all. Thank you very much. And if you have any questions, I will be more than gladly to answer them. And if you are looking for the presentation, it's on that URL. Any questions?
Do you have, or do you use, or you think is a good idea? Maybe it wouldn't solve your problem currently, but generally, do you have like a feature switches, which may be like if you see that you've got one issue or like kind of issue in one of features, you can basically just turn this feature off and investigate on a small group of people.
I've used them in the past, and it depends on. I mean, I don't see why we don't use them. Okay, because we never ran into this necessity. But I've used them in the past, in past works, and if something is wrong, it's quite good. But the problem is that if the bug is constrained to only that feature or not. In our case, the way we work or our processes work is that we are faster rollbacking the staging rollout and finding a fix, or directly hold on and fix it fast. Like we said, one of the good things we have is that we are not a very big company, and the changes are not, I wouldn't say small in the sense of we don't do nothing from 1 week, because some features that we release are significant, but but we don't have the capability to make a really huge change. So everything tends to be very focused on each release. So we know what we have been touching, and well, this was actually a very bad luck that we have. But in general, when the things that fail, we know precisely where they are.
Cool, and maybe one more question actually. So in server world, there is kind of popular concept when, an example, I have a new version of API, people usually keep the old version. Sometimes they compare the results at the same time, so it's kind of like validation in production. But actually in mobile world, I never seen anything like keeping the two implementations. Let's say you rewrite your connection layer. So basically you use the new layer, but once you see it's failing, then you switch people to the kind of old connection thing. Do you think it's a good solution? Have you ever used this kind of approach?
Actually, I don't think it's a bad solution. The problem is that sometimes you might need to be aware of which implementation each version of the app is using. But well, that's basically called an A/B testing, and you can A/B test from UI stuff to well, actually we ran an A/B stuff with Crashlytics and Firebase crashes. So some people get the crashes related to Crashlytics and some other to Firebase. In critical or where you are maybe developing or refactoring parts of the application, that might be useful. Just remember that sometimes you might need to know precisely where which two of the versions are failing. But it is a good way to focus your development. Also, if you somehow, because I'm starting to see that too, if your application is really like microservices-like, that's a very useful approach too.
Cool. Yeah, thank you very much.
Do you want a cup of
No. Oh, no. I've already some. So thanks.
I'm interested in in the detection of such a bugs with the backend, right? Have you ever considered?
Sorry, could you speak a little?
Okay, it's better. Yeah, have you ever considered implementing on your application some telemetry? So you will have a kind of like monitoring backends, responses times to to your
yeah,
backend?
we actually have this. We had those responses times on backend at the time. The thing was that it was only backend size, so we were losing information. If a user could not connect to the backend, we will be losing this information.
No, I was talking something else. You have some information from backend. That backend is saying that everything is fine, right?
Sorry, I'm not. Then I'm not picking the.
Okay, you have information from guys from backend that they are working correctly. Everything is fine. But then you might have some telemetry events on the application on the cell phones, which is measuring the
times. That's what we did with Firebase Performance. Now we have that information you're asking about. We have them on our Firebase dashboard, and you get a lot of useful information. Even for even if it's a client-based tool, it gives interesting information for backend.
In my experience, it gives you, let's say, info that some backend is having an issue, even if the backend guy is saying, "Hey, I'm okay." Yeah, so that kind of stuff.
Cool. No more questions. Thank you very much.